Let's go over how to evaluate a definite integral with an absolute value function together. We're going to evaluate this definite integral from 0 to 3 of this absolute value function of x squared minus 1 dx. To get a better understanding of what this function is, let's go ahead and look at it on the side for a moment. Real quick, if we take off those absolute value bars, this is just a regular quadratic function. And the graph would look something like this, where we have a translation of down 1 unit. But since the absolute value bars are there, notice how all the parts of the function that were negative were reflected across the x-axis. This is the function that we are looking at. We're going to be evaluating this integral from 0 to 3. So we're just going to be looking at this part of the function where x is equal to 0 and going to the right where x ends up being at 3. Now we can hopefully visualize this a little bit better. Let's go ahead and actually evaluate the integral. What we're going to do next is we're going to take that expression inside the absolute value function and go ahead and set it equal to 0 to find out some intervals. Adding 1 to both sides, we're going to get x squared is equal to 1. And if we go ahead and take the square root of both sides, we can say that x is going to be equal to plus or minus 1. Now, while x can equal plus or minus 1 here, we really only care about x equaling 1, just because we're looking at the interval from 0 to 3. So that negative 1 doesn't fall in between there. So once we find a 0, we're going to go ahead and use that to split up our original integral into some smaller parts. And so we're going to break our integral into two separate pieces here. The first piece, instead of going all the way from 0 to 3, we're going to go from 0, take a stop at 1 real quick, because that's one of our roots we just found. Then just go ahead and keep this expression of x squared minus 1 dx. But then let's go the rest of the way of our integral. So we have 0 to 1, but let's go ahead and continue the rest of it and go from 1 to 3. So we just split it up into a couple smaller intervals here. And so we have two smaller integrals here, where this integral will help us find out the area under the curve of this part of the function. And this integral will help us find out the area under the curve of the rest of the integral from 1 to 3. Next, we want to remember how absolute value functions work and how we can split them into two different expressions without absolute value bars. So when we have this expression of this absolute value of x squared minus 1, one way we could say this is if we have this x squared minus 1, that's going to be perfectly fine. But you can also go ahead and say that you have the opposite of this expression of x squared minus 1. If this first expression was inside the absolute value, then you would get this x squared minus 1. But if you also put the second one inside there as well, keep in mind because you have these absolute value bars, this negative is just going to be flipped anyway. For the second expression, if you go ahead and distribute that negative, you can just go ahead and rearrange that as 1 minus x squared. When you look at this expression here, as long as you plug in a value that is 1 or higher in for x, you're going to get a positive value. So this is going to be associated with this part of the graph. And if you go ahead and look at this expression over here, if you choose a value that's between 0 and 1, notice how if you square any fraction that is proper, it's going to be less than 1. If you take away 1, it's going to be negative. Now notice that would be down here, but if you go ahead and flip it, that's why it's going to be positive over here. So this expression is going to be associated with this part of the graph. All right, let's go back to our integrals now. For the first part, let's go ahead and just say we're going to go from 0 to 1 like we said earlier, but we're going to go ahead and rewrite this expression and say this is going to be this 1 minus x squared, right? Because we're only looking at this part for the 0 to 1 interval. Of course, we have this dx, and let's go ahead and add on that second part where we're going to be going from where? We're going to be going from 1 to 3. And then what we're going to do is we're going to use that other expression where we have this x squared minus 1. This was just going to be positive the whole time as long as x is greater than 1. Let's go ahead and throw that dx on here as well. All right, let's go ahead and integrate the first interval here. Now, if you go ahead and take the integral of 1, that's just going to be x. And if you go ahead and integrate this minus x squared, we're going to add 1 to that too. So it's going to be x cubed, but it's going to be over 3. So we're going to write minus x cubed over 3. And this is going to be evaluated from that interval from 0 to 1. Then for the second one, let's go ahead and say, all right, let's integrate this part and say we're going to add 1. So that's going to be to the exponent, that's going to be x cubed. That's going to be over 3. Go ahead and divide by that same power. And then it's going to be minus x here. And let's go ahead and evaluate this part from 1 to 3, the rest of the way. All right, so evaluating, let's go ahead and just make some substitutions here. So for this first part, let's go ahead and plug in 1. I'm going to go ahead and use parentheses here and say this is going to be 1 minus this 1 cubed, 1 to the third power over 3. Go ahead and close that off, minus. And this part's a little silly to write, I guess, but I'm just going to write it out just in case it's more clear. It's going to be 0 minus this, what? 0 cubed. 0 cubed over 3. And then for our second interval, I'm going to go ahead and evaluate that on this next line. So I'm going to go ahead and say we're going to add on, just because I'm running out of space here. Let's see, if we substitute in, it's going to be 3 raised to the third power, all over 3. It's going to be minus this 3. Okie dokie, and then we're going to go ahead and substitute in 1 here. So substituting 1, it's going to be 1 raised to the third power over 3 minus 1. All right, next we just have to clean this up a bit. The rest of this is just going to be a little bit of order of operations and such. So in this first grouping here, we have 1 cubed, which is 1 over 3 is a third. 1 minus a third is just going to be 2/3. So let's go ahead and say this is going to be 2/3 from all of that, minus. And then this is just going to be 0. 0 minus 0 is going to be 0. So 2/3 minus 0. And then let's go ahead and add on the second interval here. So for this piece, we have it's 3 cubed, just 27 over 3, which is 9. 9 minus 3 is going to be 6. So we're going to have 6 here minus. And then over here, we have 1 cubed, which is 1. 1 over 3 is 1/3. A third minus 1 is going to be negative 2/3. So I'm going to go ahead and put another parentheses in and say that's negative 2/3 here. Hopefully all these colors are helping you stay organized. And then if we go ahead and clean up just a little bit more, we have this 2/3 plus, and then this is going to be what, 6 2/3. And one more step, this is just going to end up being 7 1/3. This would be our final answer.